Hello viewers, welcome to Let's CSC. Today our topic is Hamming code. What is Hamming code? Hamming code is a single bit error detecting code. Suppose let us consider a device A transferring data to a device B. Okay, this is the device A and device B. Okay, suppose A is transferring data 1 0 0 1 1 1 0 1. Suppose this is the data transferred by A to B. In the path of transferring, suppose a transmission impairment occurred. That is, an impurity gets added by chance, unknowingly. Okay, 0 1 1 1 0 1. Can you notice the impurity added where? In this bit. See, here it was 0. Here it is 1 now. That means impurity got added and an error occurred while the transferring data from A to B. In this scenario, Hamming code comes into play. Okay, Hamming code is a single bit error detecting code. Thus, Hamming code helps us in detecting the error in the transferred data. Now, let us consider n is the transmitting data bit. Let us consider. That means n is the number of bit which n is the number of bit of transferring data. That means number of bit here 1 2 3 4 5 6 7 8. Here n is 8. And let us consider p, and let us consider p as Hamming bit, number of Hamming bit. Okay, for n bit of data, how many Hamming bit is required? How to find it? By this relation, 2 to the power p greater than equals to n plus p plus 1. By this relation, we are going to find out for n bit of data how many Hamming bit is required. Here what is n? N is 8. P will be what? In this relation, let us put a random number. Suppose first put 3. 2 to the power 3 is 8. 2 to the power 3 is 8. Greater than equals to 8 plus 3 is plus 1. That means 12. Is it correct? Is it correct? No, it is not correct. That means P cannot be P not equals to 3. Okay, now consider P equals to 4. We have to consider a greater number. Okay, not holding in 3, we have to consider more. Let us consider P is 4. 2 to the power 4 is what? 16. 16 greater than equals to 8 plus 3 plus 1. I am 13. Am I right? 8 plus 1 9, 9 plus 4 13. Okay, so this one holds. That means P will be 4. P will be 4. For 8 bit of data, P is 4. Hamming bit will be 4. Okay, now how to find Hamming code? Hamming code for this set of data. Okay, now we will see that. So our n is 8. That means 8 bit will be transferred from A to B, and P is P is 4, which is the Hamming bit. We already calculated here. How to calculate P? By this relation, n is 8, and we will have to consider P to the is 4. So P is the number of Hamming bit. So now n plus 4 is 12. So we will consider from 1 to 12 this table to find the Hamming code. Okay, from which we will find the error in the code which B received. Okay, first how to find the Hamming code. Doing this table, copy the code, this one, copy the n code. The n is here, n is 1 0 0 1 1 0 1. Copy this code from right to left, from right to left. Very important. This, if you do this wrong, then the whole Hamming code will be wrong. Okay, copy this code from right to left, leaving the 2th power places. Leaving the 2th power places, very important. 2th power places, 2 to the 0 is 1. We will leave this place and write H0 here. This is a Hamming bit. Also, 2th place, 2 to the power 1 is 2. 2th power places, we will leave this one 2. 2 to the power 2 is 4. We will leave this one 2. Sorry, this will be H1. Okay, H1. This will be H2. We will leave 8 2. This is the 2th power. 2 to the power 3 is 8. H3. If there exists a 16, 2 to the power 4 is 16. We will leave that also. According to the table, we will leave all the 2th power places and copy this n. Sorry, this is not n. This is the data transferring from A to B. Number of bit is n. Okay. We will copy this bit by bit from right to left. Now we will copy 1. All the remaining places will be filled. 1 0 1 1 1 1 1 0 0 1. Okay. Now we have to find this Hamming bit H0, H1, H2, H3. How to find out? First H0. H0 means we will consider all the numbers, all the number whose binary the last bit is 1. Okay, last bit is 1 means all the odd numbers. Leaving, we are finding 1 except leaving this 1, all the odd numbers. That means 3 5 7 9 11, right? All the odd numbers. Now see, under 3 it is 1, the bit is 1 1 3 5. Under 5 is 0, under 7 is 1, under 9 is also 1, under 11 is 0, right? Now what will be the even parity of this? Even parity will be 1 because odd number of ones are there. Okay, odd number of ones means even parity is 1. If the even number of ones are there, then the even parity will be 0. Okay, we will get one of this even parity, whose even parity will be 0. Okay, now we will find H1. H1 will be 3 6 7 10 11, whose second bit is 1. See, second bit is 1 is here 2, second bit is 1, 3, second bit is 1, 6, second bit is 1, 7 also second bit is 1, 10 also second bit is 1, and 11 second bit is 1. What will be the bit under them? See, for 3 it is 1, 6 it is 1, 7 it is also 1, 10 it is 0, and 11 also 0. Here also even parity is 1. Okay, now finding H2. H2 will be 5 6 7 12. Similarly, the third bit will be 1. We will consider them like 5 is third bit is 1, 6 third bit is 1, 7 third bit is 1, and 12 is third bit is 1. Okay, so 0 1 1 and 1, 0 and 111. Here the even parity will be also 1. Now finding H3. Okay, 9 10 11 12. The third the last bit, that means the fourth bit will be 1 also. Here it will be 0 1 1, sorry, absolutely sorry, it will be 1 0 0 1. Okay, now carefully watch. Here the number of ones are even, 2 ones are there, so the even parity will be 0 here. So what have I got the our Hamming code? H0 H1 H2 H3. What are they? H0 is 1, H1 is 1, H2 is also 1, and this is 0. So this is our Hamming code. By this code we will find the error in what B received. Okay, now we will make a table in which we will write what B received. Okay, now will B receives. Now we already got H1, H2, H3, H0. We will put them. Simply put them. We will simply put them and make a table and find. Simply put them first. Okay, 1, 1, 1, and here it is 0. Okay. Now carefully watch. This is our Hamming code. Okay, we have put the Hamming code in its place. See, 1, then it was here 1, then 1, and here 0. Okay, this was the Hamming code place, H0, H1, H2, H3, right? We have placed it, and we have placed the every bit of the data transferred. Okay, like this, as previously placed. Now we will find x0. What is x0? x0, we will choose every number whose last bit is 1. As I have told earlier, finding the Hamming code, same process. All the odd numbers, because the last bit is 1, means all the odd number, 1, 3, 5, 7. And see, under 1 it is 1, then 3 it's also 1, under 3 bit is 1, under 5 bit is 0, and like this we have chosen all the number and its bits. Now see, there are odd number of 1, so even parity is 1. Same here, x1 means we will choose all the number whose second bit is 1, like 2, 3, 6, 7, and 12. See, second bit is 1. Sorry. 2, 3, 6, 7, 10, 11. The second bit is 1. Here also, under 11 it's 1, then 0, then under 7 it's 1, then 6, 1, then 3, 1. So the even parity is 1, 1, 2, 3, 4, 5, odd number of 1. So even parity will be 1. Similarly, all this will happen. Here even parity is 0, because odd even number of 1 is there, so even parity will be 0. All these are similar process. X2 means we'll choose the number whose third bit is 1. X3 means whose fourth bit is 1. We'll choose all those number. So these are the 1, 0, 1, 1, 0, 1. So we have got x0 means x1, x2, x3. 1, 0, 1, 1. Okay, this is in binary. Now we will convert this into decimal. So this will come 11. Okay, converting into decimal. What this 11 mean? 11 means we have a error in the 11th bit. Here, see, previously the transferring data was here 1, 0 was there. When we transferred, the impurity added and error was 1 in the 11th place. So we found the error place. 11th place is the error, where the error occurred. So this is how Hamming code is used to find a single bit error. Okay, so that is why Hamming code is called single bit error correcting code. Okay, I hope you learned something from this video. If you like, please like, share and subscribe my channel, and press the bell icon to get further notification of my upcoming videos. And definitely feel free to comment your problems or any suggestion. Okay, thank you so much.